All right, so part A, we're looking at just finding an area. And they give us the clue, y equals 2 times the square root of x. So when I look at this, I'm thinking top curve minus bottom curve. Now, I thought this was y equals this 2 times the square root of x. Did I read it wrong? Is that curve y minus 2 radical x? Or did it change? Let's go. I'm going to look at the other document real quick. Oh no, it is an equal sign. Something happened there. Okay, so we're trying to find this region R. You know, if I'm going to go dx, I'm going to go top curve minus bottom curve. If I go dy, I'll go right minus left. We're going to do this part A, though, with top minus bottom. Okay? So part A, we're going to go with dx. So if we're going to go with dx, that means our limits of integration are going to come from the x-axis. That runs from 0 to x equals what? 9? I'm glad I asked you because I was going to say 6. So 0 to 9. Now all we need in here is top curve minus bottom curve. And do you want x's in here or y's in here? Okay, x's, it's dx. So what minus what? 2 squared x. Okay, cool. Yeah, that's it. Now this problem here, they don't give us a calculator, so we have to be able to go through by hand and evaluate this. So we're going to jump down to the next page, spend a little time evaluating. Notice in part A they say find. It's in question B where they say write but do not evaluate. So B, they're kind of being nice. They're saying just write it, you don't have to evaluate it. A, they're saying you got to put it all together. You have to not only write it but evaluate it. So we'll go down. Evaluate this interval. What do we want to do?
Plug in 9.
Plug in 9. Where? Right now? What should you do first? Yeah. You better do integration before you start plugging numbers in. Okay, yeah, we could rewrite this. We certainly could. If it's easier to see this as 6 minus 2x to the 1/2, if that's easier for you, I'd do that too. Okay. Okay, now what? Anti-differential. Okay, so 6x is something x to the 3 over 2, okay? What number do you want to be there? 2. Okay, so what's this? If you want there to be a 2, when the 3 halves comes down, cancel it out. So watch this. So think about the 3 halves coming down. It's down. Okay, it's going to be canceled out by the 2/3, and the 2 is still sitting there. Now we should probably clean this up. 6x. What can you write that as? How much? 4/3? So you guys said anti-differentiate. We've done that. Now what? Okay, 0 and 9. So 6 times the 9 minus 4/3 times 9 3/2. So So that subtract, what happens when you plug in 0? 0. Okay. So now we've got something equals 6. Well, let's do the 6 times 9. 4 thirds. Now, 9 to the 3 halves is kind of weird, but use what you know about exponents. You can rewrite 9 to the 3 halves two different ways. You can write it as 9 to the third to the 1 half, or 9 to the 1 half to the third. What option do you guys want? Yeah, good job. Yeah, let's do the second option. So 9 to the 2, what's 9 to the 1 half? 3 cube it, you get 27. We're not done. 27 is 9 times 3. There's 3's to show up. 4 times 9 is 36. 18. We did it. We got A done. Now let's go and we'll go and do B. Alright, B, write but do not evaluate an integral expression that gives the volume generated when R is rotated about the horizontal line, y equals 7. So let's erase this. So y equals 7 is about, let's say it's right here. Draw a straight line. So we're going to rotate that. Which way are we going to cut it, dx or dy? Dx. Cool. So when you cut it dx, we're looking at cross sections this direction right here. Now if I rotate that line segment around the line y equals 7, what shape do I get? Circles. Now, we're not just looking for that circle. We've got a smaller circle in here. Right? You rotate that red segment, you're going to get a smaller circle, so you have to subtract the two. Right? So the cross sections will look like this. So that black line that I drew is this one. The red line that I had drawn is this one here. So we just have to find the general area of one of the cross sections, and we'll plug it in into our integral. So my limits of integration are going to be from 1 to 8. Okay, now we know we're dealing with circles, right? We said we're going to subtract two circles, outer minus inner. So I've got some function of planar squared minus another function of planar squared. Look at that black line and the red line that we drew here. As x changes, will the length of that black line change? Will the length of the red line change? So what is the length of that red line? Okay, so I'm going to plug that in right here. So that's not going to change. Now, if you're going to describe if you're going to describe the length of that black line, is that going to be like with x's or with y's? With x's, right? We're using dx. We want that radius to be in terms of x. So is there anybody who knows who makes it? Is there anyone who knows how to describe the length of that black line for any given x value? Stevie says 6 minus t squared root x. So 6 is this, right, Stevie?
Yeah.
And the t square root x is this part? Nice. I think she's right, isn't she? Perfect, guys. You did it. I mean, now, yeah, you've got some computation to do, but we can do that. We can work through that. So let's go down, make some room. We'll algebraically kind of split this thing apart. First thing I see is that both of those have pi in it. I'm just going to take the pi out and put it out front. I still got my 0 to 9. I've got my 6 minus 2 square root x. I'm waiting for somebody to say, hey, go back to the prompt. What did they say? What did they say? Said don't evaluate it. So let me simplify this. Not that it's needed. But they're being nice to us. They said don't evaluate it. You can just stop there. You're done. So that's pretty cool. We did part B. I would say this. Either of these would be, I think, fine forms for your final answer. So pi r squared minus pi r squared. You cut it dx. Your limits of integration came from the x-axis. Okay. Do you want to talk part C? Okay. Part C. Alright. Region R. Region R is the base of a solid. For each y, such that y is between 0 and 6, the cross-section of the solid taken is perpendicular to the y-axis, and it's a rectangle. Let's go to the y-axis. And it's a rectangle whose height is 3 times the length. Write but do not evaluate an integral expression that gives the volume of the solid. Is this dx or dy? How'd you know, Haley? Perpendicular to the y. Very good. So we've got integral dy. What are your limits of integration? 0 to 6. What axis did those come from? Y-axis, okay. Now, you're going to have to add up a bunch of areas. Those areas are coming from what type of shape? Rectangle. What's the formula for the area of a rectangle? Three L squared. Okay, can you talk to me about that? Okay, I'm going to catch up. So you said length times width, but you commented that length is 3 times the width? Oh, so you substituted that in and rewrote this as 3w squared. Okay. We're almost there. What do we have to do now? Yeah, we want w in terms of y. So right here, this is our w. Anybody know that distance as it relates to y? L. But I have x's and y. I mean, I have an equation for x's and y's. So. It's all right. This is tough here. Is w more like x or is w more like y? More like x. Yeah, it's a horizontal distance. Well, we have some stuff talking about x and y right here.
So just solve that problem for x.
Solve it for x. Okay, so you get so first divide both sides by 2. So y over 2 equals square root x. Now what do I do to both sides? Square them. So y over 2 squared equals x. Now what? Put what in? Put in the 1/2 y squared. Okay, for what? W? Okay. So W is going to get replaced by this one right here. So, let's make some room. Alright, so the integral from 0 to 6, 3 times y2 squared. Now, is this squared right here the same as this squared? No? Okay, so that squared is a result of this one right here. So another set of parentheses. What's the exponent that goes out here? Squared. Cool. So this squared came from this right here. This should be y. Yay, we did it. Now let's pull up the solutions real quick. Let's see how we did. So we'll go back to the AP Central. What year's test was this from? Last year's. Remember what number question it was? 3. Okay. So we'll go to the scoring guidelines. Let's look for problem 3. Problem 1, problem 2, problem 3, problem 4. Hey, that 18 looks familiar. We got that. Look at it. There were 3 points associated with part A. B doesn't? Okay. Here's what we can do. Here we can look at it though. Where's our answer to B? That was our answer, right? Here was their answer.
They got 7 instead of 6.
Let's go back to our diagram.
Well, the -1 part.
The -1 part's right. If we think about how we were evolving this. We didn't move that line up one, huh? So that should be a 7. So that big radius, that black, so that was 7 minus. Okay. So we should have a 7 there. Now are we? Nice, okay. And let's go to part C. So, let's put this next to our answer. We can do that real quick. New capture. Just want to look at this stuff. Our part C, I think, is up here. So I guess the last check would say, is that the same as what we have? We have y's, they have y's. They have dy, we have dy. They have y to the 4th. I think we have y to the 4th. You have the 1/2 inside here. Okay, the first time you're going to square it, so 1/2 squared is 1/4. Now square 1/4. 1/6. We got the 3, check. We got the y to the 4th, check. We got the 0, we got the 6. We did it. So aside from that one small, error, having the 6 instead of the 7, We were perfect.
And it won't matter which one you write on the test.
It won't matter which way you write it on the test. I don't think there were any directions in C that said, like, be sure to simplify it this far. So nicely done, guys.